So the next problem we're going to do involves trig substitution, trig functions, and I'm also going to add in here that we're also doing an improper integral. So improper integral just means that we're integrating up to infinity. So the first thing for these improper integrals is that we want to write it down as a limit. So the definition for an improper integral, if we're going from 5 to infinity, we have dx over x squared, square root of x squared plus 25. So the way you write this is we choose some parameter. We do limit, and I'm just choosing t as my variable. T goes to infinity. From 5 to t dx over x squared, square root of x squared plus 25. Okay, so this is just the limit, and you always want to do this as your first step. So now once we've done this as our first step, I'm really going to be working with this for now. And then at the end I'll take the limit. So let's just look at this integral. 5 to t dx over x squared, square root of x squared plus 25. So this here, we have something squared plus 25 under the square root, is going to tell us that we're going to be using a trig sub. So the way we're going to use a trig sub, we have to figure out which one we want to use, right? There's a couple different ones to use. The way you can write down some sort of rules. There's some rules of what depending on what you see, you're going to use the right trig integral or trig sub. I like to just remember two trig identities and then find out which one to use from there. So I always start by writing down sine squared y plus cosine squared y is equal to 1. So no matter what y is, that's the case, right? And then if we divide everything by cosine here, cosine squared, we get tangent squared y plus 1 is equal to secant squared y. So these two are really all you need, and really all you need is this one, because we get to the second one just by dividing by cosine squared. Okay, then I try to match it up. Well, what does this look like? Well, which one of these looks like what I have? Well, if you look at this, I think about this as some variable. I'm going to call this variable maybe u squared plus 1 is equal to secant squared, right? So this looks a lot like what I have here, right? So we're going to be using this one. And the way I'm going to get there is I'm going to multiply everything in this tangent squared expression by 25. So I know that 25 tangent squared of y plus 25 is equal to secant squared of y. Okay, so now what I'm going to do is I'm going to say let x equal 5 tangent y, or I could say x squared is equal to 25 tangent squared y. Oops, sorry. Yep, that's what I want. Yep. And then I'm just going to replace this. So now that I have this replacement, we're going to put this in the integral. So let's look at our integral. First thing, actually, before we just do any replacement, we're going to have to find our dx. So we have dx is equal to 5 d by dy tangent y dy. And well, what's the derivative of tangent? The derivative of tangent is secant squared. So it gives us 5 secant squared y dy. Okay, so then we're going to go ahead and look at this, and now we're going to plug in everything. I'm going to drop the bounds for now. I'm going to move on to another page. So we have this integral dx over x squared square root of x squared plus 25 is equal to, well, we said dx. If we go back, we said that dx is equal to 5 secant squared y dy. So I'm just going to plug this in. Secant squared y dy over, and x squared, well, x squared is just 25 tangent squared y. And then we have our square root, which is 25 tangent squared y plus 25. I have room here. Okay. Good. So now everything's in terms of y. We've successfully done the transformation. So now we can go ahead and see this and bring out a 1/5 here. But really what we want to do is we want to do something with this inside. So that's the whole point. We did this trig sub. So let's write this out now. We have a 1/5 outside. We have integral secant squared y dy. It looks a little bit intimidating now. We have this tangent squared y. But now I'm going to bring 25 out of everything. So here, I'm going to write this. I'm going to just do an extra step here. I'm going to factor the 25 out. And then now I have tangent squared y plus 1. Right? So then we could factor this out. So we have 1/5 integral secant squared y dy over, if I factor that out, I get a 5 tangent squared y, and then I have times the square root of tangent squared y plus 1. So now we see, if we go back, oh, tangent squared y plus 1, what is that? Oh, we already said we know what this is. Tangent squared y plus 1 is just secant squared. So let's go to the next page and replace tangent squared y plus 1 with secant squared. So now we have 1 over 25 on the outside. We have our secant squared y dy over tangent squared y and times the square root of secant squared y. So this is exactly why we did this trig sub, right? So now we can get rid of whatever's in the square root because we have the square root of something squared. So this is 1 over 25. I'm going to draw this on the next line instead. Is equal to 1 over 25 integral secant squared y dy over tangent squared y times secant y. Okay, this is great. Now we can get rid of one of these, get rid of that squared. So now it's a little bit hard. I mean, it looks hard still. We have our secant y over tangent squared y. That still looks hard, but it's not so bad. So whenever you get to this step, let's write everything in terms of our sines and cosines. Secant y is 1 over cosine, right? Tangent is equal to sine over cosine. So now we have 1 over tangent, so we have cosine squared y over sine squared y, and then we have dy still. Good, now we can do another cancellation, and we have this. And what we end up with is 1 over 25 integral cosine y over sine squared y dy. Now this also looks a little bit intimidating, but we're in a good place. Now we like when we have sines and cosines together because we can just do a pretty simple u sub. U is equal to sine y, du is equal to cosine y dy, which is what we have on top. So we get 1 over 25 integral du over u squared, which I always like to write u to the minus 2 du. And the reason I do this is because now I can easily write down 1 over 25, and I end up getting a minus u to the minus 2 becomes minus, minus u to the minus 1. So I can write this now. I have minus 1. If I sub back in for my u, I get minus 1, 25 sine y. Okay, so we're not quite done, right? At the end we have to put everything back in terms of original variables, which are x. So let's figure out how we're going to do that. We want everything back in terms of x. How did we define y? This right here, this defines y. So we're going to use that. We have x is equal to 5 tangent y. So let's go ahead and draw a picture. This is where you draw your triangle. Okay, this angle is going to be called y. And this equation tells us that x over 5 is equal to tangent y. But we also know that tangent y is equal to opposite over adjacent. So what we do is we just match these up. So my opposite is x, my adjacent is 5, and then for the hypotenuse I have square root of x squared plus 25. Now what we wanted to do was find sine of y. So sine of y, well sine of y is opposite over hypotenuse. So in this case this is x over the square root of x squared plus 25. Now we can plug this back into what we had here. So we had minus 1 over 25 sine y. So minus 1 over 25 sine y is equal to minus square root of x squared plus 25 over 25x. Okay. Now that we have this, we can go ahead and work on our original integral. What we had was the limit as t goes to infinity, 5 to t dx over the square root of x squared plus 25. Now the whole point is that we just found this integral, right? That was everything we just worked for. So now we can write this as the limit as t goes to infinity. We've already found the integral. In fact, it's right there. Minus x squared plus 25. Oops. Over 25x. And this is going to go from 5 to t. Now I'm going to bring my 1 over 25 out. Actually, no, I'm going to leave that in there. Now I'm going to write this. This integral is equal to, or once we evaluate everything, we just have minus square root of t squared plus 25 over 25t. Whoops, we need a limit in there. Let's throw this. Make sure we say that's there as well. And then we have plus square root of 25 plus 25. That's 25 times 5. Now I'm going to go ahead and write this. I'm going to write this other term first. So I have 2 times 25 over 5 times 25 minus the limit as t goes to infinity, and I'm going to rewrite this a little bit. I'm going to write this as t squared 1 plus 25 over t squared. So it'll be obvious why I write it like this in a second. I'm just evaluating the limit. You could do this limit however you like to do limits. This is how I like to do limits, so I'm going to do it this way. Okay, so then this first term, I'm going to split up this. So I wrote it like this, so I can split up the square root. Square root of 25 is just 5, right? So we have 5 times 25. These guys are going to cancel. Let's draw that in red. And then we have minus the limit as t goes to infinity. And the reason I did this is now I can do the same thing. I bring this out and I have 1 plus 25 over t squared over 25t. And I can cancel my t's. Now, how we do the limit, we see in the limit, this thing goes to 0, right? So now what I'm left with, I think I have to go to the next page here, but if we remember, we have is equal to the square root of 2 over 25 minus, now we look at this is just going to be 1 over 25, right? 1 over 25. So you can write this square root of 2 minus 1 over 25. Now this is our answer for the integral. So you often also get problems that will say, does the integral converge? And that just means, did we get something that wasn't equal to infinity? So yes. Because integral is a number, right, instead of infinity. Okay, so we're done.